Feruza Jubaeva is a member of Team Data Launchers who participated in the 2025 NASA Space Apps Challenge, a global hackathon that brings together diverse teams to tackle real-world problems using NASA's open data alongside space-based data from agencies around the world. Feruza presented AIVYRA, a risk forecasting platform that gives the user insights on weather patterns, flood risk, extreme heat, wildfires, and more. The reports it produces can help you make informed decisions before you buy, rent, or build. Check out the platform, links in the description box below.
Hello, I'm pleased to be here. My name is Feruza Jubaeva. I'm a graduating master's student in my final semester at NYU, Management and Systems. And today I will be presenting a project that me and my team Data Launchers had presented in the 2025 NASA Space Apps Challenge. The prompt we were addressing is commercializing lower Earth orbit. So the way I will be presenting is first presenting the project that we had developed back then during the Space Apps Challenge, and then what we have been working on up until now. The approach that we took to addressing commercializing lower Earth orbit was to understand what are the key issues being faced, and therefore who would pay in order to address these issues. To have a better understanding of this, I would like to start off with a slideshow. So here we have the names of our teams. I am Feruza Jubaeva, labeled as the strategist over here. So to begin with, once upon a time, a man in California had posted a photo of the sunset saying that it looks very beautiful tonight. But that was no sunset. That was an extreme wildfire. Continuing on, the USA over the past several decades have sustained many climate disasters, which have been tracked since 1980, and the cost of them have exceeded over $2 trillion, probably has already reached $3 trillion by the present day. And so this is the issue that we are trying to resolve. The way that we would resolve it is by building a climate risk forecasting engine. This engine would be able to forecast climate risks at a granular level all over the world for specific zip codes, perhaps even specific properties in far pointed futures and distant points in time. This is an overview. This brings us to the answer. At the time, our project was called Next to Us. So the solution would be Next to Us. This engine would be meant for multiple users, including enterprises, individuals, something that you could have maybe in your hand at your laptop, something anybody could use, and it would output forecasts on demand, unlike, say, big expensive reports from big companies that only enterprises would be able to have access to. And the data that it would draw from would be from live satellite and historical data sets. So live satellite would be the very open space project that was used throughout the NASA Space Apps Hackathon. And the historical data sets would be stuff like NASA data sets and especially NOAA. So here is a demo video of the first iteration of the project. This is a Figma demonstration. It begins with a map of the world that you had seen earlier. And then each point would represent a point for which a forecast was developed. Now, each forecast includes multiple different climate data points, which is something that has changed over time, which climate data we use. And in its current iteration, we have the AIVYRA app, which is able to give you a climate profile of any location at its current time. And in future, we will be including climate forecasts up to maybe 10, 20 years into the future. So to start with an example, let me start with, say, a Brooklyn location. And here we have an overview of what the climate is like in its current state, some of its historical data, what sort of uses it could be for, so in terms of health, in terms of its risk score for people who care about property risks in current and in future. That is Next to Us, now AIVYRA, and I'm very pleased to present this project. Thank you.